Okay, welcome to our lesson on common factoring. So common factoring is very similar to what we just with greatest common factors. Common factoring, let's say, remember the distributive properties. So remember when you're given a question like 2 times x plus 1. And then you have to multiply, you have to distribute the 2 into the bracket. So you have 2x plus 2. So here you're expanding. You're going from the multiplication to the expanded polynomial. Well, common factoring is actually just going backwards. So taking this and going back to the unmultiplied form. So if you were given 2x plus 2, how do you get back? Well, what you're going to do is you're going to say, look at these two terms, 2x and 2, and say, what's the greatest common factor? And hopefully you know from the last video that the largest number which divides 2x and 2 is just 2. So we take that number outside the bracket. We take it, put it front. And then we just, inside the bracket, you're going to write, well, if I divide 2x by 2, I would just have an x. And if I divided 2 by 2, I would just have a 1. So I've gone sort of just in the reverse. So you can do, many examples like this. Let's say you're given 5x squared plus 10x. So remember, now we want to go backwards. We want to write this as something times something in a bracket. Well, what's the greatest common factor of 5x squared and 10x? So look at the number. What divides 5 and 10? 5. What divides x squared and x? And remember, you take the lowest power, so that would be x. So our greatest common factor should be 5x. And now the first number in the bracket will be 5x times what gives you 5x squared? That would just be x. 5x times x is 5x squared. Plus 5x times what gives us 10x? And that would be 2. 5x times 2 is 10x. So this would be an example of factoring. We've common factored this to get this. And you can just check by doing the reverse, by expanding. So if we expanded 5x times x plus 2, so just use distributive property, 5x times x, 5x squared, 5x times 2 plus 10x, which is back to that original. So we're good. We checked and we got it right. So that's common factoring. So let's do another one. So common factor. So the questions will say probably common factor or just factor. So here's our example. And we can see lots of different types of examples. We'll just do a few right here. So let's say something like x cubed minus 5x squared. So there, what's the greatest common factor to x cubed and 5x squared? Well, the number here is 1, so there isn't really the largest number which divides 1 and 5 is just a 1, so we don't write 1. But then for the variables, the largest common factor for x cubed and x squared would be x squared. So then inside the bracket, you'd write what number multiplies x squared to gives you x cubed. That would just be the x, minus what times x squared gives you 5x squared, which would just be 5. And you could again check that by expanding. Just do a few more. You could have, it doesn't have to be just binomials. You could get, say, 5x cubed minus 10x squared plus 25x. So what is the largest number which divides all three of these, 5, 10, and 25? That would be 5. What's the largest variable with exponent that divides x cubed, x squared, and x? That would be x. So there's our greatest common factor. So what times 5x gives us 5x cubed? That'd just be x squared. What times 5x gives us minus 10x? That'd be minus 10x squared would be minus 2x. And 5x times plus 5 is equal to 25x. So again, that's our greatest common factor. One thing we should note is that you have to take the greatest common factor. So let's say you do something like, I don't know, let's say the question is 4x squared minus 8x, and you're asked to factor, common factor. Actually, a lot of times you're just going to be asked to factor, and you have to figure out that that means common factor. And you thought, okay, what divides 4 and 8? And you recognize, okay, 2 divides 4 and 8. So you said, okay, it's 2. And then what times 2 gives us 4x squared? That would just be 2x squared. And then 2 times minus 4. So that you'd have that. And you'd be kind of right. I mean, this, if you checked, if you expanded this in, you'd get back this. And that's true. But you're not done factoring unless the inside bracket, or unless all the brackets, we're going to have more brackets. So not fully factored. So that means that there's a common factor for both these terms, right? There's a number which divides 2x squared and 4. So I could factor further. And I mean, you could just continue. You could say, okay, well this 2, I'm going to leave that 2. But then I can common factor another 2. So I'll multiply by another 2. And then 2 times what gives me 2x squared? Well, that's just x squared. And 2 times what gives me minus 4? That's just minus 2. And then I can multiply these 2's out in front and just get 4x squared minus 2. And now this is fully factored because there's no common factors in the bracket. Or if, you know, it would have been better if you had just recognized that 4 is a common factor to begin with, and then just written 4x squared minus 2. There, you do it in one step rather than 3. So it's very important that you always take the greatest common factor rather than just the first factor you recognize. Okay, so it's important. You got to take the greatest common factor. And let's just do a couple more examples where you get more variables. So let's say you've got something like 15x squared y cubed minus 20x to the 5y squared. So again, just in parts, what's the largest number that divides the coefficients? So in this case, 5. What's the highest power of x that divides both these? So x squared is the lowest, so it's always the lowest, so x squared. Y cubed, y squared, so y squared is smaller. So there's our greatest common factor, and then the rest is in the bracket. So what do I need to multiply 5x squared y squared by to get 15x squared y cubed? So looking at the numbers, I need a 3. Looking at the x's, I don't need any more x's. And looking at the y's, I need one more y. So 3y times this gives me that. Minus, now what times this will give me this. So looking at the numbers, 5 times 4 gives me 20. Looking at the x's, I have x squared, I need x to the 5. So I'll need 3 more x's, so x cubed. Looking at the y's, I don't need any y's, so I'm done. So this times this should give me back that. Let's just do one more. Let's do something a little more complicated. 7. Sometimes I won't use x's and y, so let's do that. Now that's n plus okay, so again, looking at the numbers, what's the largest number which divides all these? 7. What's the largest number that divides the m's? So we have m to the 5, m squared, and just m to the, you can think of that as a 1. So m to the 1 is the largest that is common. N cubed and 5 be n. So there's our greatest common factor. What do I need to multiply this by to get this? So 7, 7, I'm good, I don't need any more numbers. M to the 4, in the ends we're good, plus 7 times what gives us 49, be 7. M times what gives us m squared, that'd just be 1m. N times what gives us n cubed, n squared, plus 7 times what gives us 21. M times what gives us m, nothing. And n times what gives us n to the 5, n to the 4. So there we go. And you should just always check, is there any greatest common factors in there? Nope, fully factored. Good. Oh, one more example I just thought of that might throw you off, might not. Well, let's just keep it simple. Let's say you have something like 7x squared plus 7. Okay, so largest thing that divides both of these would be 7. So 7 times what gives us 7x squared? That would just be x squared. And 7 times what gives us 7? Here's where it might throw you off. 7 times 1 gives you 7. So if this number is already this number, it's just a 1. So that's greatest common factoring, or that's common factoring.